Now, welcome to today's class. Today, I have an amazing topic of study. Now, the topic of study I want us to discuss today is all about electrochemistry. Now, as you know, electrochemistry is derived from a unit known as thermodynamics. Yes, so here, the question I am having here is from that is a stoichiometry of Faraday. And I want us to follow the concepts I want to give you today so that you will be able to answer whichever question that will be provided under stoichiometry of Faraday. Now let us look at the question I've put in place today so that we can be able to get to know the solution to it. Now the question is, if 612 coulomb of charge is passed through a solution of copper to nitrate in aqueous state, calculate the number of moles of copper metal deposited, given that 1 Faraday constant is equals to 96,500 coulomb. Yes, now you've been told to get the number of moles of copper metal deposited, having been given the charge as well as the Faraday constant. Now, what is the solution towards this problem? Because that's our main area of concern. So I'll now come here and say now solution there. Now, when you look at the question, I'm being told to calculate the number of moles of copper metal deposited. Now, the formula I want to give you is very essential that will enable you to know how to calculate the number of moles having been given a charge of whichever equation. And therefore, the formula states that to get number of moles, we just write NO that way. So number of moles, specifically it is number of moles of copper. So number of moles of copper being deposited. The formula states that you just get a charge because you've been provided with a charge over N times the Faraday constant. So this is a formula I want us to use so as to solve this equation here, and it is the same formula that you should be using to solve whichever equation under stoichiometry of Faraday, as long as you've been given a charge and the Faraday constant. So remember the formula so as to be able to understand and to solve whichever equation you will be given. Now, after writing the equation that way, as well as the formula, your work is just to begin substituting. Check what you've been provided with and what you are supposed to find. Now here, I have the number of moles here. You are supposed to check whether you've been given the number of moles. Now here you've been told to calculate the number of moles, and therefore it is not provided, and that's what we want to get. And here we have the charge. Check whether you have the charge. You've been told that if 612 coulomb of a charge is passed, so that one means that we already have the charge, and therefore there is no need of finding it. We shall just be substituting it here. Then down here we have N. How will we get N? Because it is not here. Now to get N, you are required to write an equation of deposition of copper at the cathode, because copper is a metal that is positively charged, and therefore it must just be deposited at the negative terminal of the battery, and possibly it is the cathode. That's why we shall be writing an equation of cathode so that we can see the charges to show the N which we want to get here. And remember, the Faraday constant is here, so there is no need of finding the Faraday constant. So my first step is to calculate N, and as I've told you that to calculate N, you are supposed to get the equation at the cathode. So you'll come here and write equation at the cathode. Now, how will I get equation at the cathode? As you know that at the cathode, electrons are always gained. Since electron loss at the anode are always gained at the cathode, and therefore to show that electrons are gained at the cathode, we shall show the electrons on the reactant side. That is it. So you ensure that your electrons in the equation here is at the reactant side but not at the product side. That is it. So I'll come and say, because it is copper, so when you probably when you decompose copper to nitrate, you shall come up with copper 2 ions, that is copper 2 ion, it is positively charged, so that is aqueous there, plus electrons. Why electrons here? Because we've said that the cathode electrons are gained, and to show that electrons are gained, you must write electrons at the reactant side but not the product side. That is very important. Now when after gaining electrons, the copper will end up being solid there. Now after writing that equation is not complete, and therefore you need to complete it. Now to complete that equation there, you are required to balance the charges, because the atoms are rebalanced, because here we have 1 1, but the charges, when you look at the charges at product side here, it is 0. Therefore I must ensure that my reactant is also 0. So I already have 2 here, and here is -1. So when you take 2 minus 1, it is 1, and therefore it will not be equal to 0. Therefore you need to be using an appropriate coefficient that you will use under electrons here, so that you can balance the charges both at the reactant side as well as the product side. So the appropriate coefficient here is 2 there, because when I put here 2, that one means that will be 2 positive minus 2 negative here, because electrons are negative, so it will be 2 minus 2, and probably 2 minus 2 is 0, and therefore my product charge shall be 0, is equals to my 0 here. So the reactant side will be 0 as well as the product side shall be 0 charge, and therefore after doing this you will have balanced the charges there. Now after getting the correct equation there, you will now be able to get n, because n is now 2 as provided there. After getting 2, you will be substituting, you just substitute it here, because everything now you have, we were having the charge as 612, you have a Faraday constant 96,500 coulomb as well. We've gotten the number of n, that is 2. So our work is now to substitute. Now we'll come here now say that the number of moles here is now equals to charge. And what is my charge? My charge is 612. So I'll come here and write 612 over the n. And what is the n here? I've gotten it as 2 times the Faraday constant. The Faraday constant I've provided with us 96,500. Now when you work out this, you can use your appropriate calculator to display the provided values there. So I have 612 there, divided by n as well, I divide by 96,500. When you perform that, you will end up by getting 3.17 etc. times 10 raised to -3. Negative 3 power means I divide the result here by 1,000. So when you divide 3.171, when you round off, over 1,000, you will end up by getting 0.00317 moles. So that's what right here. So it will be 0.00317, because I am rounding up here, moles. And therefore you shall have gotten the correct solution to the provided question, and you shall have derived to your answer. Otherwise, hope you've enjoyed the lesson and you've marked the basics that I've quoted in the provided lesson of today. And therefore, I'm urging you to share the video to as many of your friends as possible, so that they can also benefit to increase the success in academics. Otherwise, let us meet in the next class.